Alright guys, Miss Pipel here. Today in this video we're going to be talking about the concept of density and how to calculate density. Go ahead and get started. So first, density is a measure of the mass or the amount of stuff there is packed into a certain amount of space or a unit of volume. So the equation to calculate it is very simple. Density is equal to mass over volume, how much stuff per unit space. Okay, so our units then, our unit for mass is always going to be grams, and then we can use two different units for volume, either milliliters or centimeters cubed. You will see later on how those two measurements are related. So we can also think about this. We've talked a lot about looking at how tightly packed molecules are. So when you have something that's a solid and those molecules are very tightly packed, that's going to be pretty dense. Whereas if you have something that the molecules are much more spread out, there isn't as much matter in that amount of space, and so that's going to be less dense. Okay. This is an intensive property of a substance, so we can actually use density to help us identify a substance. So if you were to have just a random sample of, a metal, and you were to find that the density of that specific sample there was 7.8 grams per milliliter, then we could identify that as a sample of iron. So it can be used then to identify what it actually is that you're talking about. So when we talk about density, we also can talk about the effects of density, and this is something that generally you guys probably already know, but things that have a lower density than whatever they're sitting with are going to float, and things that have a higher density will actually tend to sink. So there's a really cool experiment that can be done, not really an experiment, I guess a demo. It's called a density column that you can see pictured over here. And so in this, there's a whole bunch of liquids, and they're labeled on the left there, each with a different density. And there's another reason why they don't mix with each other, which we're going to talk about later on this semester. We'll be able to explain that later, but the main reason they're in the order they are is because of their density. So you could claim then that honey, right, is the most dense of all of those liquids, where your lamp oil is going to be the least dense of all those liquids. Okay, and then what's kind of fun is you can put solid objects in those and see kind of where they end up. So you have a bolt down here, so that's actually more dense than all those liquids because that's sunk all the way to the bottom. Where the cherry tomato here is more dense than the water, but less dense than your milk, definitely, and kind of sitting right in the middle of that dish soap. So it might have pretty similar density to the dish soap. And the ping pong ball, which is mainly air, right, is going to be sitting on the top there, because that's the least dense of all of those things. But, okay, this is not going to be with all things, and you know that, right? You don't have your phone sitting on a table and it just sinks if it's more dense than the wood of the table or the plastic of the table, whatever it is. So this is only going to occur when you have something that objects are able to flow through, right? So that's going to either be a liquid or a gas. When you're comparing density of two things, one of those components has to be a liquid or a gas in order to actually have that sink or float effect, which again we know, and I don't feel like I should have to say, but we just got to remember that for later on. All right, so doing the actual math here, and I want you guys to watch carefully about how I set this up and how I label all of the components of this problem. So this question here says, an unknown sample of metal has a mass of 460 grams and a volume of 51.3 centimeters cubed. What is the density of the sample? Okay, so there's my question statement. I'm always looking for the question. What am I looking for? So I'm asked for density. So that's what I'm going to try and solve for. There are two other numbers given to me, and they're pretty clearly indicated in this problem, which is kind of nice. It says you have a mass of, so your M there is going to be 460 grams, okay, and your volume is 51.3 centimeters cubed. Okay, so pretty straightforward. So what equation relates all of those three factors there, density, mass, and volume. Well, that's our density formula that we saw earlier. So I'm going to write that formula out. Okay, we're solving for density. That letter is already, or that variable, excuse me, is already isolated. It's already all on its own. So all I have to do now is go ahead and plug in my mass, my m value here, and my volume value here, and do some math. Notice I kept the units in there. Okay, that's going to be important as we go through the semester, so make sure that you always keep your units visible in your work. And so we're going to go ahead and do some math really quick, so get your calculator out. Alright, so we should get, let me get my pen back here, 8.97, and then I'm always going to have my units attached to that. So that's going to be grams per centimeter cubed, just as the units I showed you on that very first slide here. So, sorry, that's not the neatest, but hopefully you guys can still read that. 8.97 grams per centimeter cubed is the density for this sample. Okay, notice my answer has 3 significant digits in it, 1, 2, 3. Luckily that's all my calculator gave me, so I didn't need to worry too much about rounding. And each of my factors included in the problem also had 3 significant figures, so that works out. All right. The next question here says, what is the identity of the metal? So as I mentioned earlier, you can use the density. It's an intensive property, so you can use it to identify what a substance is. And on your reference sheet, you guys actually have a list of about 10 or so metals that they have their densities listed as well as some other properties. So you can find that it's on page 1 of your reference sheet, which is like the back of yours. And so this has our metals here. And if you remember, the density we just calculated was 8.97 grams per centimeter cubed. And so we're going to look for a value that matches that or is close to that in our reference table here. Now, of course, this is based on data, so data is not always 100% accurate. There is always some error in measuring, as you remember. So we're going to find the one that's closest to that. And I would say that my 8.92 value up here is closest to that, which would make this sample copper. Okay, there's another value that's a little bit close, right? We have 8.90 down there. But I would say that 8.92 is definitely closer, right? 0.02 closer to the value we calculated. Okay? All right. One more thing I want to go through really quick is talking about rearranging your formula here. Okay, remember that we may have a problem that you're given, you're given the density, you're given the volume, and you need to solve for the mass. Okay, right, so your density formula is density equals mass over volume. That's the pure formula, that's the formula you'll see on your reference sheet. We can rearrange that, okay, if we were to need to solve for mass, for instance. Okay, we can multiply both sides by volume. We have to get mass all by itself. And in order to get rid of that volume piece, we do the opposite of what's currently being done to it. So it's currently being divided, and so we're going to multiply by that in order to get rid of it. So you would find that one other equation you could use is that mass is equal to volume times density. And you could also see that now if we wanted to maybe solve for volume, if you divided both sides by density, you could find that mass is equal to, or excuse me, volume is equal to mass divided by density. Okay, so these would be 2 other working equations, but hopefully you should be able to rearrange that equation on your own. Now, whichever one of these equations you need to use depends on the given factors in your problem. So you guys will see on your practice sheet that there are a couple different versions where you might be given 2 of the 3, or you might need to calculate the volume and then plug that in. But make sure that you're looking at what all those values mean and listing out your givens like we did here in the beginning of your calculation example. And we will go over this in class tomorrow. Please write down any questions you have, and I'll be sure to answer them in class. Have a good night.